Hi there, welcome to my channel Mando to Fundu. In this video, I am going to discuss about the solution for minimum size subarray sum problem. Let's look at the problem description. We are given an array of positive integer nums and a positive target, and we have to return the minimum length of a subarray which sums up to this target value. If there is no such subarray, then we have to return 0. Let's take a look at the example 1. So here the target value is 7 and the nums array has 2, 3, 1, 2, 4, 3. So in this, the first subarray which adds to 7 is 1, 2, 4. That is 1 subarray which is of size 3, and then 4 and 3 of size 2. So minimum is 2. So we have to return 2. So in the case of example 2, the target value is 4 and the nums array has 1, 4, 4. So the minimal length is the array size 1 subarray of only one element in it. And the third one is the target 11. It doesn't have a subarray which sums up to this value, so we return 0. Let's look at the approach to solve this problem. So we are given an nums array 2, 3, 2, 1, 4, 3 and the target value is 7. So the expected output is 2. So here there are two approaches. One is a brute force. So in this, we traverse the input array. On each iteration, we try to find the subarray which adds up to 7 for the rest of the array. For example, from 2, we do the entire thing. And from 3, we add the rest of the things. So it will be like, in the worst case scenario, it will be like order of n squared. The second approach is a sliding window approach. In this, we maintain two pointers, start and end. They both point in the beginning of the array, and then we advance the end pointer on each iteration. And whenever we advance the end pointer, we add the corresponding value to the sum variable. So once that sum becomes greater than or equal to the target value, then we advance the start pointer until the sum value becomes less than the target value. So each time we advance the start pointer, we decrease that value pointed by the start from the sum. Then at the end, when the end pointer hits the last element, then we finally return the min length. In this approach, the time complexity is order of n. Let's look at the flow chart. Input for this procedure is the nums array and then the target value. So first we initialize the start and end pointer and then the minimum length and count variable. The minimum length will be set to the maximum integer value, and the count is initialized with the number of elements in the input array, and then the start and end pointer point to the first element of the input array. Okay. Then we enter the outer loop. So here we check whether all the elements are processed. If so, we just simply return the min length. Otherwise, we add the element pointed by the end pointer to the sum variable. Then in the inner for loop, we check whether the sum is greater than or equal to the target. If so, we inside the inner loop, we compute the number of elements from the start and end index, the current start and end index, and then we compare that with the current minimum value. Whichever is less, we assign that to min length. Then we decrement the value pointed by the start pointer from the sum variable, and then we increment the start index. So in this loop, we advance the start pointer. In the outer loop, we advance the end pointer. So once the value becomes less than the target value, then we break out of the loop, and then we processing the next element pointed by the end. We increment the end, and then this loop continues. Once this processed all the elements, it will come out and return the min length. Let's move on to coding. First, I initialize the start and end pointer to 0, so that they point to a first element, and then the count variable is initialized with the length of the input array, and then the min length is set with the maximum integers value. Then I enter the for loop, and then The for loop will run until the end pointer meets the number of elements. Then I initialize the sum variable to 0. So in each iteration of the outer loop, I add the current value pointed by the end pointer to the sum variable. Then in the inner loop, I check whether the sum is greater than or equal to the target. Then I compute the current length of that subarray which forms that sum by subtracting the start from the end pointer, adding 1, and then update the min length, whichever is less between the current length and min length. Then I subtract the value pointed by the start pointer from the sum variable, and I advance the start pointer. Next I increment the end pointer. Once I come out of the outer for loop, I check whether the min length is still max integer value. In that case, there is no subarray which adds up to the target value. So I return 0. Then finally I return min length. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. So we are given in this input array and the target value is 7. The expected output is 2. So the length of the minimum subarray is 2, 4, 3. First I initialize the start and end pointer to 0. Both are pointing to the first element in the input array. The count is initialized to the number of elements in the input array, and the minimum length is set to the maximum integer value, which is 32767, and the sum is initialized to 0. So here we are entering the for loop. We check whether the end pointer is less than the number of elements in the array. Yes, it is. So then we add that value pointed by the end pointer in the array to the sum variable. So when we enter, the min length is 32767, sum is 0. When we leave this iteration, the min length is 32767 and the sum is 2. So we just add this number to the sum variable. Because this sum is less than the target value, we are not entering the inner loop, and we simply increment the end pointer to point to the next element in the array. So the end pointer is advanced now it is pointing to number 3, and that value will be added to the sum variable 2, so which becomes 5. So this sum is still less than the target value 7, so we are not entering this inner for loop. Iteration 2, when we enter, the min length is 32767, sum is 5. And now if we add this value, and the sum becomes 7. Okay, and now this meets the condition of the inner for loop. So the sum is greater than or equal to the target value. So we are entering in the inner loop and compute the current length, which is n minus start plus 1. Because the array is indexed from 0, so we simply subtracting the start index from the end plus adding 1. Next we update the min length by comparing the current length with the current min length. So in this case 32767, and the current length will be 3. So the min length is updated with the value 3. After that we subtract the value pointed by the start, which is 2. So that's why we see the value 5 for the sum variable when we exit the first iteration of the loop. So once it becomes 5, this loop will break and then come out, and we increment the end pointer to point to the next element, which is 1. So now it is pointing to 1, and then the start pointer is advanced once in the previous inner loop execution, so it is now pointing to 3. Okay, so when this value is added to the sum becomes 6, which is still less than 7, so we are not entering this inner for loop. Then we increment the end pointer. Now the end pointer points to the value 4. In the outer loop we add that value to the sum variable, so the sum will become 6 plus 4, 10. So this meets the condition for the inner for loop. The sum is greater than or equal to the target. So we are entering the inner for loop on the iteration 0. The minimum length so far we computed is 3. The current length is 4. So in this case, the end pointer end minus start plus 1 is 4. So we are the current length is 4, but this is greater than the so far computed min length. So we are not updating the min length. Then we subtract the value pointed by start. So in this case 3. So 10 minus 3, 7. And then we increment the start pointer. So now the start is pointing to the value, the index 2. Okay. So now if we add this value, so now still the sum is greater than or equal to the target value 7. So in the next iterations we are entering, and we are computing the subarray length. In this case it will be 3, and which is the same as the previously computed min length. So still it will be min length will be 3, and so min length is still 3. And then we subtract the value pointed by the start. We can subtract 2 from 7, so it becomes 5. And then we advance the start pointer. Now the start pointer pointing to the index 3. Okay, and then because this condition, the sum is less than the target value, so we break out of this loop and we increment the end pointer. So now the end pointer points to the last element of the input array, and when we enter the fifth iteration, the min length is 3 and the sum is 5. Okay, so in the outer loop we add the last value 3 to the sum variable, so it becomes 8. So this meets the condition for the inner loop we are entering inside. So in this case the size is 3. In the inner loop 0th iteration, the current length will be 3. Current length is 3. Current length is 3, and which is same as the previous lowest value of min length. So we are not updating in this iteration, but we subtract the value pointed by the start from the sum, so which is 1. So the sum value becomes 7, and we advance the start pointer. Now it is pointing to the index 4. Okay, so in the next iteration when we enter, the min length is 3 and then the sum is 7. We compute the current subarray's length. So in this case it will be end minus start, which is 2, and then we subtract the value 4 from the sum, so the sum becomes 3. And then we check minimum value between the current length and min length. This time min length is assigned with value 2. So when we come out of that iteration 5, we have a minimum length 2, which is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis. This solution actually does addition operation and then comparison and then the subtraction operation. Okay, so let's see how many times this addition operation is executed, how many times this comparison operation is done. So let's take the case 1, so which has input array with all ones, and the target value is 5. So in this case if we add all of them, then we get 5. The subarray with minimum length is 5. So in this case the outer loop executes 5 times. So the inner loop execute only once at the end. Okay, so the time complexity for this case is order of n. Let's take the case where the num array has 2, 3, 2, 1, 4, 3, and the target value is 7. As I explained in the code flow section, the outer loop executes 6 times and the inner loop executes 5 times in total. So which is, if we add all of them, which is double the time of the input, almost double the size of the input array. So if we remove the constant factor out of this, then the time complexity is order of n. The nature of the input determines how many times that operations are performed. Okay, so if there are multiple subarrays which adds up to 7, so in that case we see more number of inner loop execution. If there is only one, then we see only one iterations in the inner loop. Okay, but outer loop, regardless of the nature of the input, the outer loop executes n number of times, where n is the number of elements in the input array. So with respect to the space complexity, we do not allocate any additional space. We use just few variables. So in space complexity is order of 1. Thanks for watching this video. Have a great day.